Hello friends, in this class we'll see about the area and the perimeter of a square, that is a squared, and perimeter is 4a. This the values, that is area and perimeter, you have learnt in your lower classes. The same we will go through the concepts. We'll just brush through the concepts. Now, what is area? Area is nothing but the total, this full area, this shaded area is called as the area of a square. Okay. Now, what do you mean by perimeter? Perimeter is nothing but the surrounding boundary of the square. This surrounding length is called as the perimeter of a square. Okay. So now what is the area of a square? It is a squared and perimeter is 4a. Similarly, in the case of a rectangle, you have the length and the breadth. The area is nothing but the shaded portion. This shaded portion is the area of a rectangle. It's given by length into breadth, and perimeter is given by 2 into length plus breadth. The full surrounding length or the boundary of this is called as the perimeter, nothing but 2 into length plus breadth. Always the area is denoted by m squared, meter squared or centimeter squared. Okay. The case of a triangle, the area of a triangle is given by, this is the base and this is a perpendicular bisector is the height of the triangle. Nothing but half into base into height. And what is the perimeter? It is 3a, or where a is the length of the triangle, or it is nothing but s1 plus s2 plus s3, where s1, s2 and s3 are the length of the three sides of the triangle. Now we'll go to the area of a circle. A circle area is given by pi r squared. What is pi r squared? Pi r squared is nothing but pi into r, where r is the radius. And what is the value of pi? Pi is given as 22 by 7 or 3.14. Similarly, the case of a parallelogram, the area of the parallelogram is given by base into height. So, in the case of a parallelogram, this is the height. The perpendicular bisector is not the perpendicular bisector. This is given by the height and B is the base. Okay. Now, the perimeter of a parallelogram is given by 2 into S plus B, where S is the length of the side and B is also the base of the parallelogram. I hope you got it. This is the formulas for the different shapes. Okay. Now let us go to the next problem, that is Mrs. Kaushik has a square plot with a measurement as shown in the figure. She wants to construct a house in the middle of the plot. A garden is developed around the house. Find the cost of developing a garden at the rate of rupees 55 per meter squared. Now you will be confused whether I have to find the area or the perimeter of the square plot of the house and all these things. See, whenever you are asked to find the garden or any pathway or anything like that, you have to go for the area. That is the entire, if I take this to be the plot, this full area I have to find out. From that I have to subtract the area of the house. I hope you get it. The area of the square plot minus area of the house will give me the area of the garden which has to be developed. This is the garden, isn't it? So the shaded portion is the garden. So this shaded portion, if you want to get the area of the shaded portion, I have to subtract the area of the square plot from the area of the house. I hope you understood. You will be getting such problems, so understand this concept nicely. Now let us what is the side of the square plot? It is given that the side is 25 meters. Therefore, area of the square plot is nothing but 25 into 25, which is equal to 625 meters square. I hope you get it. Okay. Now we have to find the area of the house. Now to find the area of the house, what is the length of the house? Length of the house is 20 meters and breadth of the house is 15 meters. It is given in the diagram. Therefore, area of the house is equal to length into breadth, which is equal to 20. It is a rectangle, isn't it? So 20 into 15, which is equals to 300 meters square. Therefore, what is the area of the garden? Area of the square plot minus area of the house. So 625 minus 300 is 325 meters squared. Now what is the cost of developing a garden? It is rupees 55 per meter squared. The total area is 325 and the cost is 55 meters squared. So the cost of developing the garden is nothing but 55 into 325, which is nothing but 17,875 rupees. I hope you get it. 55 into 325, if you multiply, you will get 17,875. Okay, now we'll go to the next problem. The shape of a garden is rectangular in the middle and semicircular at the ends, as shown in the diagram. We'll see the diagram now. Find the area and perimeter of this garden. The length of the rectangle is 20 minus 3.5 plus 3.5 meters. Now we will see the diagram. Now this is the diagram of the rectangular field. Now this is the rectangular area. It is covered by two semicircles. Now you should understand one thing. It is given the entire length along with the semicircles, it is 20 meters, whereas the diameter of the semicircle is 7 meters. So when the diameter is given as 7, what is the radius? Radius is nothing but 7 by 2, which is 3.5. So this length is 3.5. Similarly, here also this is 3.5. I hope you understood it. See, the total length is given along with the semicircle, length of the rectangle. The total length is given along with the semicircle. We know that in the case of a semicircle, the radius we have to take, the length of the radius on both the sides, which is 3.5. How did I get it? I was told that this full length is 7 meters. So even if I cut it into half, it will be 3.5. That is nothing but the radius. Okay. So what are we given? Total length is equals to 20 meters. Diameter of the circle is 7 meters. Therefore, radius of the circle is equal to 7 by 2, which is equal to 3.5 meters. So here one 3.5 and here one 3.5. I hope you get it. Length of the rectangular field is equal to 20 minus 3.5 plus 3.5. We subtract the 3.5 from both the sides. So we get 20 minus 7 is equal to 13 meters. What is the breadth of the rectangular field? Breadth is 7 meters. This length is 7 meters. Area of the rectangular field is nothing but length into breadth, which is equals to 13 into 7, which is 91 meters squared. Now what you have to find out is, here you have to find out the area of the rectangle along with the area of the semicircles. Okay. You know that the area of a circle is pi r squared. This is a semicircle, so it is half pi r squared. How many semicircles do I have? I have 2 semicircles, so it's 2 into half into pi r squared. I hope you got it. Okay. So area of 2 semicircles is equals to 2 into half into pi r squared. Now this is nothing but 2 into half into 22 by 7 into 7 into 3.5 into 3.5. What is 3.5? 3.5 is the radius, isn't it? So 2 into half into 22 by 7 into 3.5 into 3.5 is 38.5 meters square. I hope you understood how we solve this problem. Okay. Now we'll go to that same thing. They have asked to find out the perimeter of the two semicircles. That is 2 into pi r. What is the perimeter or the circumference? Anything you can say of the semicircle is nothing but 2 pi r. So we have got two semicircles. So it actually for a semicircle it is pi r. For two semicircles it is 2 into pi r. So 2 into 22 by 7 into 3.5 is 22 meters. Perimeter of the garden. How do you get perimeter garden? This side is 13, this side is 13 because 20 minus 7, isn't it? So this is 13. That is only the rectangular thing. 13 and 13. With that, the perimeter of the semicircles, that is 22. So 22 plus 13 is equals to 48 meters. I hope you understood this. How we got 13 two times the length of the rectangular plot. After subtracting the length of the semicircles, we got 13, isn't it? There are two lengths, so it is 13 plus 13. Then the circumference of these two semicircles, we got it as 22. When we add all that, we get 48 meters. Okay. Now we'll go to the next formula, that is area of a general quadrilateral. We will just see how we deduce the equation. Now let us take this parallel quadrilateral ABCD in such a way that I draw a perpendicular bisector from B to the side AC, and similarly this is called as H1, and from D to the side AC is also H2. Now area of this quadrilateral is nothing but area of triangle ABC and area of triangle ADC. Now how do we know from the area of a triangle that half into base. Now this is the base, isn't it? So half into AC into H1 plus half into AC into H2. I hope you understood this. H1 and H2 are the heights of the two triangles. Okay. And AC is the common base. So I will remove half and AC outside. I will get H1 plus H2. Now what is AC? AC is nothing but the diagonal. So half D into H1 plus H2 is the area of a general quadrilateral. I hope you get it. In this, D is the diagonal, H1 and H2 are the heights of the two triangles. Okay. Now we'll go to the next one, which is the area of a rhombus. Area of a rhombus is nothing but area of this triangle plus area of this triangle. So area of triangle ACD plus area of triangle ABC. What is it? Half into AC is the base into OD. OD is the perpendicular bisector plus half into AC into OB. Let me take half AC common outside. OD plus OB. This OD plus OB is nothing but DB. Isn't it? Or BD, anything. So half into AC into BD, which is nothing but half into D1 into D2. Now what is D1 into D2? D1 is the diagonal 1, that is AC, and D2 is the diagonal 2, that is BD. So this is the formula for a rhombus. There we saw the formula for a standard quadrilateral. This is the formula for a rhombus. Now this is a trapezium. Now in the case of a trapezium, the area of trapezium is given as half into height into A plus B, where A and B are the length of the opposite sides of a trapezium. Okay. I hope you have understood this. So that is all for this class. Bye students.